Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105. This video is all about the packet tracer examine the ARP table. So this packet tracer is belong to the chapter 5. So the first that we will see here is the addressing table. So it has a device, interface, MAC address, switch interface. So it has data here. Then the objectives. Part 1, examine an ARP request. Part 2, examine a switch MAC address table. Part 3, examine the ARP process in remote communications. So background. This activity is optimized for viewing PDUs. The devices are already configured. You will gather PDU information in simulation mode and answer a series of questions about the data you collect. So part 1, examine an ARP request. Step 1, generate ARP or the ARP request by pinging 172.16.31.3 from 172.16.31.2. So the first that we will do is letter A, click 172.16.31.2 and open the command prompt. So this one, this PC, then the command prompt. Then enter the ARP dash D. So ARP D. Then we'll enter. Then enter simulation mode and enter the ping command ping 172.16.31.3. 2 PDUs will be generated. Let's see here. We'll in the simulation mode, then we will ping the 172.16.31.3. So here. So we will ping the 172.16.31.3. So enter. So it says here that 2 PDUs will be generated. So here are the 2 PDUs. It has 2. The ping command cannot complete the ICMP packet without knowing the MAC address of the destination. So the computer sends an ARP broadcast frame to find the MAC address of the destination. And letter D, click the capture or forward once. So we will click once here. Then the RPDU moves switch 1 while the ICMP PDU disappears. So disappear in this one, the switch 1 appear. Then waiting for the ARP reply. Open the PDU and record the destination MAC address. Just open the PDU. Then and record the destination MAC address. Is this address listed in the table above? So no. These are the tables. So then let's proceed to the E. Click the capture forward to move the PDU to the next device. Again, we'll click 1. Then there is a question here. So how many copies of the PDU did switch 1 make? So it has 3. So this one, the switch 1, it has a 172.16.31.3, the 172.16.31.4, and the router 1. Then F is, what is the IP address of the device that accepted the PDU? So, that accept the PDU is this one, the 172.16.31.3. Then G, open the PDU and examine layer 2. Then, what happened to the source and destination MAC addresses? So, source become destination fff.fff.fff. So, 4 F's, then 3. Then, turned into MAC address 172.16.31.3. So, this one. So, this is the fffff.fff.fff. And this one is the destination, the 172.16.31.3. Then, let's proceed to the next. H. This one. Click capture forward until the PDU returns to 172.16.31.2. So we will then there is a question, how many copies of the PDU did the switch make during the ARP reply? So it has only one. So step 2, examine the ARP table. Note that the ICMP packet reappears. Open the PDU and examine the MAC addresses. So, open the PDU and examine the MAC addresses. Examine the MAC address. Then there is a question, do the MAC addresses of the source and destination align with their IP addresses? So, the answer is yes, they align. Here, the source here is 172.16.31.3. Also here, the source is the 172.16.31.3. This one is the same, and their destination IP is 172.16.31.2. They also the same. So the answer for that question is yes. Then switch back to real time and the ping complete. So we will switch to real time. Then click 172.16.31.2 and enter the ARP-A command. So the 31.2 172, this one. Then enter the ARP A. So question, to what IP address does the MAC address entry respond? So it is in the 172, this one. The answer for that question is 172.16.31.3. Then next is the in general, when does an end device issue an ARP request? So when it does not know the receiver's MAC address. So part 2, examine a switch MAC address table. Generate additional traffic to populate the switch MAC address table. From 172.16.31.2, enter the ping 172.16.31.4 command. So in 172, then the command prompt, then we will ping 172.16.31.4, then enter. Then click 10.10.10.2 and open the command prompt. So after we ping that, so we have 4 replies. We got the 4 replies, so it means that they have the connection. So that this one, that 2, so this one, and open the command prompt. Then enter the ping 10.10.10.3. So ping 10.10.10.3. So the question is, how many replies were sent and received? So this is the answer. So sent is 4 and received is also 4. So we have 4 replies were sent and received. Then step 2, examine the MAC address table and the switches. So we are now in the step 2. Click switch 1 and then the CLI tab. Switch 1, this one, and then the CLI tab. Then enter the show MAC address table command. Show MAC address table command. So do the entries correspond to those in the table above? So yes, these are the MAC address table. Then click switch 0, then the CLI tab, enter the show. So this is the switch 0, and then the CLI tab, enter, and then show MAC address table. Do the entries correspond to those table above? So yes. Then letter C is, why are 2 MAC addresses associated with 1 port? So the answer for that question is, why are 2 MAC addresses associated with 1 port? So the answer is because both devices connect to the 1 port through the access port. So both devices are connected to 1 port. So that's why they are associated with 1 port. So part 3, examine the ARP process in remote communication. Step 1, generate traffic to produce the ARP traffic. So letter A is click 172.16.31.2 and open the command prompt. Close this one, and the 172.163.1.2, this one, and then open the command prompt, then enter the ping 10.10.10.1. So ping 10.10.10.1 command. So we have for reply, so it means that it has a connection. Then type ARP, then -A, then it has a question. What is the IP address of the new ARP table now? So the new address is the 172, this one, 172.16.31.1. So letter D, enter the ARP-D to clear the ARP table and switch to simulation mode. So we will first ARP D. Then we will click for the simulation mode. So there, the ARP table is cleared now because we changed it into the simulation mode. Then repeat the ping to 10.10.10.1. So we will repeat the ping. One ping 10.10.10.1. So how many PDUs appear? So let's wait. So it has two. This one, 2 PDUs. It has two. Then click capture forward. Click the PDU that is now at switch 1. So then click the PDU that is now at switch 1. What is the target destination IP destination address of the ARP request? So the destination now is the 172.16.31.1. Then next is the destination IP address is not 10.10.10.1. Why? So the destination IP address is the 172.16.31.1. So the question is why does that 10.10.10.1 is not the destination IP address? So this is the answer. So the gateway address of the router interface is stored in the IPv for configuration of the host. If the receiving host is not on the same network, the source uses the ARP process to determine a MAC address for the router interface serving as the gateway. So that is the answer. Step 2, examine the ARP table on router 1. Switch to real-time mode. Click router 1 and then the CLI tab. Real-time mode, and then click router 1, this one, and then CLI tab. Enter privilege exec mode and then show the MAC address table command. Okay. After the enable, show MAC address table. Then the question is how many MAC addresses are in the table? So 0, it doesn't have a MAC address here. So we can see here. This command means something completely different than the switch command show MAC address label. So they are different commands. So that's why 0 is the answer. They have a different command. Then the last is enter the show ARP command. Show ARP command. Show ARP. Show ARP. Then enter. Is there an entry for 172.16.31.2? So we will locate that. So it doesn't have, so it times out. So that's all for this video. Thank you for watching.